All right, good day, guys. We'll be talking about linear inequalities, and like I do say, the first aspect of me explaining this stuff is the introduction aspect, and a linear inequalities is in different categories. So, like I said, I love to drop short videos on things so you can understand the first explanation very well. And most students they don't like when videos are too long. You get what I'm saying? They feel like, oh, this is 30 minutes, this is 20 minutes. Oh no, I can't check it out. Even without even clicking on it to even see how it could help and impact their life. So talking about linear inequalities. That's what I'm going to start from today. The topic is inequalities, but I'll talk about linear inequality for today. And like I said, each slide has its own explanation. So starting from there, linear inequalities deals with our less than, your greater than equals to, and your less than equals to. These are the signs it deals with, right? And most cases why they involve an inequality is simply because, let's assume now, there is not, it's not most cases that this idiot can work for. Yeah, this idiot here, it's not most cases it can work for. And let's assume now, like I said, Nigeria and America. Look at American dollar and look at Nigerian naira. You can't say Nigerian naira is equal to American dollar. That is even impossible, far impossible. So we either say Nigerian naira is what is less than, how you get what I'm saying, American dollar, or we say American dollar is greater than Nigerian naira. And inequalities help to understand that very well, right? And there's something I want to explain to you guys is that, let's assume you have something like this. 3x plus 2 equals to 4. You all know that this is a normal linear equation, right? Where you'll be having your 3x being equals to 2 and your x will be equals to 2 over 3. Yes. The same thing is applicable to your linear inequalities. But there is one exception in linear inequality. But before I move to all this, let me quickly break this down. What does all this sign, what do they signify? When I tell you that x is greater than 3, what am I trying to say is that these two categories, greater than and less than, they are being classified as a strict inequality. A strict inequality in the sense that whatever is at the front, they don't bring it here. Never. You will never see there. What do I mean? If I'm to tell you that x is greater than 3, that seems that I'm trying to say x being greater than 3, I can't involve 3. Why is that? If I'm to put 3 here, you'll be having 3 greater than 3, and that is impossible. But if I'm to put 4 upward, it makes sense, right? 4 greater than 3, 5 greater than 3 till infinity. So if I'm to tell you that x is greater than 3, I'm listing out the values starting from 4, then to 5, then to 6 till infinity. Are you getting what I'm saying? That is why they are being called a strict inequality. And moving on to the other one, if I say if I'm to say x is less than 3, state is applicable to this. I can't say 3 is less than 3. Impossible. I'm to start from a lower number like 2 less than 3. So therefore, if x is less than 3, I'm starting from 2 to 1 to 0 to -1 to -2 until infinity, like that. So that is why they are being called a strict inequality. Now talking about weak inequality. These two are the sign for weak inequality. And why do they call them weak inequality? Simply because they don't like to move on to next level. They love to bring along their friends, and that is a good thing. You don't just simply because this one now, this is the trenches where this person had before. This trenches, but it was like, I have to step up now. This is a fucking trenches. Sorry for the word for. So this is a trenches. So you have to step up to some other things like that. Let me move it from level 0 to another grand level now. But for this is a generous person whereby he loves to take along anything whenever he's going. Now I'm to tell you that x is greater than equals to. I'm trying to tell you that x is greater than and also still equals to. So if you are to put 3 here, I'm letting you to know that one more time, x is equals to 3 and also x is greater than what? 3. So if x is equals to 3, if I'm to put 3 here, it will be equals to 3. And our value will be giving me 3, 4, 5 till infinity. So same thing is applicable to our x being less than equals to 3. X being less than equals to 3 has to be involved also. Like I said, it takes its trenches along with it. 3, then 2, then your 1, then your 0 till your infinity, like I said. Are you get what I'm saying? So till negative infinity, like that. So guys, this is the one important aspect, the first category. Now the second important thing you need to know under this is that when dealing with inequalities, unlike your normal linear equation, there's just one exception, is that whenever you multiply or you divide both sides, by minus, you have to make sure that you change the sign of the inequality. Either you multiply both sides by minus or you divide both sides by minus, you have to make sure that you change the sign of the inequality. And there's one thing I also want to call your attention to, is that let's assume you have something like this: 6x greater than 3 plus 12x. When looking at this question now, you would see that most people will love to bring 6x here, simply because 12x is greater than 6x. But please, in that process, if you are someone that you don't really understand something, you might get yourself confused on how to switch the sign. So let's start with this as example 1. 6x, you are looking for x greater than 3 plus 12x. Now in this process, this category now, I will advise you that always let your x stays in the left hand side. That is, 12x comes to meet 6x here, not 6x going to meet 12x there. This is the head of the house for now. So the wife has to come here. Now having 6x, when 12x crosses the Yanokwaja border, it has to become a negative 12x, then greater than your 3. Now 6 minus 12, most people also, they find this little thing hard. When I tell them 6x minus 12x, even some people that are adults, they're like, what's this? Let me now give you guys a little bit logic on this. You having your owing and your borrow and your have and you want to also give. Now take this as negative, take this as positive. So if I am owing you 12 naira and I was like, okay, my bro, I want to pay, you get what I'm saying? Like, you want to pay 6 naira out of the 12 naira. If I'm to pay 6 naira out of my debt, I'm still owing the person, which is 6 naira. So an owing takes what sign? Negative. So that will be negative 6. Then add your x to the front, less than 3. Now guys, we can easily divide both sides by the coefficient of x here. Are you with me? And for you to understand things better, this would be over minus 6 over minus 6. Or you can easily divide it by 6 first. That is by saying minus x minus 6x divided by ordinary 6 greater than 3 over ordinary 6. Are you with me? But I guess this is very, very easier to quickly nurture. Now if I'm to start from here, 6 we cancel out 6, I'll be having minus x greater than, you have 1 over 2. But I'm not done. I'm looking for x, not minus x. So from here, I will just multiply everything by minus. And remind you, whenever you multiply both sides by minus, the inequality sign changes. So multiplying this by minus gives me plus. That will be x. Then the inequality sign will change. If it's greater than, it changes to less than. If it's greater than equals to, it changes to less than equals to. So I'll be having less than minus 1 over 2, as you can see. But moving on to here, also the same thing. Minus cancel, minus 6 cancel 6. Then x would be less than, the sign changes because you are dividing both sides by minus. Minus plus divided by minus, plus divided by minus gives us minus. Then 3 divided by 6, you have 1 over 2. So that is what x being less than minus 1 over 2. So I guess this should be the one of the most important thing you need to understand. The key logic, this and this, under the linear inequalities. So let us take another example. Let's say example 2. Let's say you have 3 into bracket 4 minus 2x, then greater than equals to 4 into bracket 5 minus 2x. Now guys, you know, we open the bracket for this, right? And that will be 4 times 3, that's 12, minus 3 times 2, that's 6x, greater than equals to 4 times 5, that's your 20, then minus your 8x. So you collect like terms, CLT. So collecting like terms, I told you guys, make sure that your x is always at the left hand side so that you won't confuse yourself. You have minus 6x, then plus 8x, greater than equals to 20, then minus 12. So minus 6x plus 8x gives us 2x. Greater than equals to 20 minus 12. This gives us 8. Divide both sides by a coefficient of x, which is plus 2, ordinary 2. Then over 2, 2 cancel out 2. Your x will be greater than equals to what? 4. As you can see, this is a normal answer. Simply because, and the sign does not change. Why? You are not dividing or multiplying any side by minus. So we move to the next slide to understand some other things again under linear inequalities. This is more like an introduction aspect to linear inequalities. And my name is Clipto Quanta. Thank you.